Have you ever wondered why your ears pop when you ascend in an airplane or go diving deep underwater? What's really happening? It's all about the invisible force that surrounds us every day, atmospheric pressure. Imagine you're at the bottom of a swimming pool. You can feel the weight of the water pressing against you, can't you? Now swap that pool of water with a pool of air. That's right, air has weight too, and the weight of the air above us is what we call atmospheric pressure. It's like a gentle giant, constantly pressing down on everything at the surface of the Earth. The force exerted by this air blanket changes with altitude. Picture climbing a mountain. As you go higher, there's less air above you, hence less atmospheric pressure. That's why it's harder to breathe at the top. Conversely, when you go below sea level, the air pressure increases because there's more air above you. Now, how do we measure this invisible force? Enter the Aneroid Barometer, a nifty little device that helps us keep tabs on atmospheric pressure. The term aneroid means without liquid, differentiating it from its older cousin, the mercury barometer. The Aneroid Barometer contains a small, flexible metal box called an aneroid cell. This cell expands and contracts as the atmospheric pressure changes. As the pressure increases, the cell contracts, and as the pressure decreases, the cell expands. These movements are then magnified through a system of levers and gears to move the needle on the dial, giving a reading of the atmospheric pressure. Let's put it in a simpler way. Imagine a balloon filled with air. When you press on it, the balloon compresses, right? That's similar to what happens with the aneroid cell in the barometer. When atmospheric pressure presses on the cell, it contracts, and the needle moves. So, let's do a quick recap. Atmospheric pressure is the force exerted by the weight of the air above us. It changes with altitude and can be measured with a device called an aneroid barometer. The aneroid barometer uses an aneroid cell, a small metal box that expands and contracts with changes in pressure, to give us a reading of the atmospheric pressure. Understanding atmospheric pressure and how to measure it is not just for weather predictions or scientific studies, it's also crucial for our daily lives, affecting everything from how our bodies function to the weather patterns that determine our climate. So the next time your ears pop in an airplane or on a mountain hike, remember, it's all about the pressure.